Okay, describe the data in context. So these are exam scores, 25 from Mr. Donahue's 25 statistics students. So when you're describing this, you want to talk about shape. So the shape is going to be skewed left. So center. So you would talk about probably the median. The median, you probably want to talk about it in context, the median exam score for Mr. Donahue's 25 students. There are 25, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 13, 12, 13. So the 13th student from either left or right is going to be an 89, I believe. Let me double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The 13th student is that. Measures of variability. So you could choose different ones. IQR would be a really good one. So this is the middle point right there. So there are 12 data values to the left of that. So 1, 2, 3, 4, 5, 6. So these two are in the middle of that. Oh, I could just use the data values. Why am I using the, it's so much easier. So 89, 89. So this is the middle of the data, we think. So there's 12 to the left, 1, 2, 3, 4, 5, 6. So between 83 and 85 are two middle ones. So Q1 is going to be 84. You can also use your calculator to get all these. We'll do that in a second. From the right, 1, 2, 3, 4, 5, 6. So these two are in the middle of the top half of the data, because this is kind of like not really in the top or the bottom. That's the median. And so between 93 and 93, so Q3 is 93. The IQR is 93 minus 84, or 9. So variability, the IQR equals 9 points on the exam score. And then outliers, there appears to be an outlier at 65. We can double check. We could use the Q1. I don't think there's anything to the right. We don't have to do that. So Q1, which is 84, minus 1.5 times IQR, which is 9. So let's get our calculator out. So 84 minus 1.5 times 9, 70.5. So 70.5, right in here is the cutoff for the outliers. So 65 and 70 are both outliers because the fence is at 70 point. The lower fence is 70.5. So find the 5-number summary. I've just about found it there. Let me just show you the calculator how to find it. So if you type the data in, so I typed it into Listen Spreadsheet page. I called it exam. Hit the home key, go to calculator page, do not go to Scratchpad. Menu 611. X list is called exam. There's the 5-number summary. Start with the min. Min is 65. Let's see, I thought Q1 was 84. Median, I thought was 89. Good, I got that all right. It's good to double check this kind of stuff when you can. So the only ones I don't have, the list is so the min and the max. Were 65 and 96. I guess you could get it from, from there as well. And the median in Q1 and Q3. I already listed those above, so I'm going to not waste time on the screencast. Draw a box plot. Okay, so we have to draw a box plot of this. So draw your scale. We got to go from 65 to about 100. So I'm going to go by 5, 65, 70, 75, 80, 85, 90. It's not quite spaced as evenly as I wanted, but oh well. 100. We can call a title for this, so the exam scores. And then you plot the 5-number summary, right? So 65, you're going to plot a point up above the graph. 96 is your max. Q1 was 84. Q3 is 93. And the median was 89. The box goes around Q1 and Q3. Draw a line for the median. This is not an outlier. So the biggest value, remember, these were both lower outliers, right? So 72 is the smallest number that's not an outlier. So I'm going to go only connect to that point, to the last point that's not an outlier. And I need to make sure that the other outliers plotted there. So 70 is an unconnected point. That's also an outlier. I think your graph should look like that because the next question is the mean or median distribution larger. So which one's larger? The mean got pulled to the left, so the median is larger. By the way, you can definitely just check that here too as well. If you look, the mean is 86.96, that's X bar. Median is 89. So 89 is bigger, the mean is larger. Why? Because it's skewed to the left. And so the mean is smaller than the median. Don't forget your calculator can also do the box plot. We can even see if we did it right. So go to data statistics. Once you have your data in, choose a value down there. The exam is the variable. Then go menu, plot type, box plot. And there you go. And you can even hover over the values. It tells you all those important values. Q1, median, Q3, max. And they scaled theirs slightly differently, but we did it by 5s. Pretty good first problem. Just solid, actually what you would hope to get something. So this one, so on August 7th, Barry Bonds hit 756 home run, breaking the all-time home run record. Does that make Barry Bonds a better home run hitter than Aaron? So let's compare him with a side-by-side stem plot, right? So Bonds and Aaron. Use the plot to write a few sentences discussing the similarities and differences in the distribution of home runs for Bonds and Aaron. Show your work when checking for outliers. Oh, that's nice to know that we need to do that. Okay, so there's no lower outliers. So shape, they are both skewed right. And it's hard to see, like Aaron, wait, are they both skewed right? So Bonds is skewed right. Sorry, I thought they were both skewed right. I think actually Aaron is skewed left. Aaron's home runs. We're talking about in context. What are these? These are, yearly home run totals is skewed left. So the medians, so you can count them out and find the median. So doesn't say how many each of them had, how many years. I counted 23 for Aaron. So if that's true, then the 12th term would be in the middle, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think 34. So for Aaron, the median was equal to 34 home runs. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22 seasons for Bonds. So 11th and 12th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 34. So for Bonds, the median was 34. I didn't catch that until just now. So they're the same. You wanted to use comparative words, in this case, the same. Variability, you could do IQR, right? So there are 22, so there are 11 to the left of that median. So the sixth term, 1, 2, 3, 4, 5, 6. So this guy, I think Q1 would be 26. Q3, going from the top, 1, 2, 3, 4, 5, 6. So I think 44 would be Q3. So IQR, 44 minus 26, or 18. There are 22, so the 11th and 12th. So you kind of cut that in the middle. So there's really 11 above, 11 below. So the sixth term, 1, 2, 3, 4, 5, 6. So Q1 is 25. And from the biggest, 1, 2, 3, 4, 5, 6, I think 42 is Q3. So 17, so IQR 17. Okay, so Aaron has more variability. That's the comparative word, because IQR was equal to 18, whereas Bonds had less. His IQR was equal to 17. Finally, outliers. I'm pretty sure this is an outlier. 73 home runs in one season for Bonds. Was he on steroids? Possibly. I think he maybe admitted to it. I don't remember. Okay, so, but it was big news. So outliers. So how do you check? It says to show work when checking for outliers. So to show work for that, you're going to do the one. So the upper outlier is going to be Q3, or 44. So the upper fence equals 44 plus 1.5 times the IQR, which is 17. So 44 plus 1.5 times 17. 69.5. Okay, so 69.5 is in there. That's the fence. So 73 is outside the fence. So it is an outlier. We can see that for sure. Here's a multiple choice. So a lobster fisherman is keeping track of the productivity of a set of traps. He placed his favorite location below the numbers of lobsters in these traps over the course of 12 different hauls. According to the 1.5 IQR rule, which values are outliers? So there are 12 different traps. So the 6th and 7th, 1, 2, 3, 4, 5, 6. So these two are in the middle. So 5 is the median. So there are 6 numbers to the left of that. So those two make up the Q1. Those two make up average to make Q3. So Q3 minus Q1 would be 7 minus 3, which is 4. So that's my IQR. Okay, so let's do the lower rule. It's Q1, which is 3, minus 1.5 times 4 in this case. That's the lower fence. The upper fence is at Q3, which is 7 plus 1.5 IQRs. So you might get your calculator out. 3 minus 1.5 times 4, and 7 plus 1.5 times 4. So negative 3 and 13. Negative 3, 13. Ooh, outlier. So 14 is the outlier. Pie chart at right describes the distribution of favorite school subject for 300 high school students. Oh, math, 26%. English is the favorite. Come on, guys. Math was a favorite for 26 students. It's not quite accurate. This is percent, so I don't think that's right. 96 students. I don't know. That could be right. So what's 32% times 300? This was rigged. 32% times 300. 96. Ooh. I think that sounds right. History, English, and the arts are the favorite subjects of less than half the students. History, English, it's already 43%. And arts, that's 51%, or less than half, that's more than half, that's not right. No student said that Spanish was their favorite. Oh, that's so sad if that happens. We don't really know, because other could have said that. It's possible. It's possible someone say Spanish favorite. I don't know. Most of the English students were female. We have nothing about the gender of students here. So following is a histogram showing the actual frequency of the closing prices of a particular stock on the New York Stock Exchange over a 50-day period. Which class contains the third quartile? Okay, so there's, to say how many each? 50-day period. Okay, 50-day period. Okay, so the third quartile. So like the 25th and 26th term. So it's the, if you think about this, right, there's 25 terms, then kind of a break in 25 terms. That's where the median is, right in between two groups of 25. If you break that into two groups, you've got a group of 12, and one in the middle, which would be the median, whatever that is. So you're really looking for the 13th term from the right, I think. Oh man, this is hard to tell. I think this is 1, 1, 3, 2. Okay, so I want to find the 13th term. 1, 2, 3, 4, 5, 6, 7. 14. 14. So I want the 13th term. It's got to be in here. Between 30 and 40. Hopefully I'm writing these. I'm not checking them yet. I guess I could. The answers are at the back there. Which statement is true? In a distribution that is skewed to the right, the median is larger than the mean. Well, that's not true. If it's skewed right, the mean gets pulled with the skew. So 50% of scores in distribution are between the first and third quartile. That seems true. This middle 50% is between the first and third quartile. The third quartile is always greater than the mean. We don't know what the mean is. We know what the median is in a box plot. The median of a distribution is always greater than the mean. That's not always true. Could be true. The range of distribution is typically less than the interquartile range. It's not really possible. It could be the same, I guess. Can't be less. The mean birth weight of a sample of infants born at a certain hospital in the month of April was 128 ounces with a standard deviation of 10.2, which is following the correct interpretation of the standard deviation. So think of standard deviation as typical deviation or difference from the mean or distance from the mean. Typical distance from the mean. So it's not really like a margin of error. I don't think that sounds right. Distance between the weight of each infant born and the mean weight was on average. Is that a terrible way of saying it? That probably is it. Difference between mean weight and the median weight. No, definitely not that. About half the infants born in April weighed, that we don't know, like possible. All the infants born, it's not like a margin of error, so it's got to be D. And that's pretty close to typical difference or distance from the mean. Which of the following statements about standard deviation is true? So these are just qualities about it. Standard deviation measures the typical distance from the data points that are from the median. That is not true. It should be from the mean. Regardless of what units are used, standard deviation has no units. Well, standard deviation is units. I don't think that's right. Standard deviation is always a non-negative number. That is correctamundo. You're squaring values in the formula. There's no way it can be negative. So I am going to cross out B. The data is measured in hours. Standard deviation would be measured in hours squared. No, that's variance. Standard deviation is resistant outlier. No, mean is not resistant, so there's no way standard deviation would be. It's typical different from the mean. 100 people work at lifetime internet services. Suppose that after a particularly successful year, the president of the company decides to double his own salary and not change anyone else's. Beautiful move. Assuming the president makes more than anyone, which of the following statements about the changes? So he becomes an outlier. He might have been an outlier to start with, but he's even a greater outlier for sure. The mean and standard deviation will increase. Yeah, they're not resistant, so they're going to increase. But mean and IQR are resistant, so I don't think they're going to be affected. I think that's it. The sample was taken of the salaries of 20 employees in a large company. Following box plot shows the salaries in thousands for the year. Based on the box plot, which of the following statements is true? The maximum salary is between 60 and 70. No, the max is between 70 and 80. The minimum salary is 20,000. I don't know. It doesn't look like it even gets down to 20,000. The range of the middle half of the salaries is about 20,000. That's probably it. Median salary is about 40. Now the median is like 48-ish or 49-ish. That's the median right there. 25% of employees make more than 70,000. No, 25% is here. 25% make more than 60,000 or more, something like that, but not that. Questions 11 and 12 refer to this setting. 40 students took a stats exam having a maximum of 50 points. The distribution of scores is given in the stem and leaf plot. Which of the following are the correct median and interquartile range of the distribution? You could type this in your calculator if you wanted to. So there are 50. So I need 25th and 26th to make the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. People work at lifetime internet services. 25 and 26. I think that's the 25th and 26th term. So 38 would be the median. Oh, no, there's not 50 people. We have to figure out how many people there are. Did they not tell us? I gotta count the number of people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I counted 40 people. That might be right. Okay, so the 20th and 21st. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 20 and 21st. Right there. So the 32nd. So I know it's one of these guys. Interquartile range. So that's the was the 20th and 21st term. So there's right down the middle. So there's 20 terms left to that. So the 10th and 11th will make up the Q1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These two guys. So 23 is Q1. And the 10th and 11th were on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 44 is Q3. IQR, 44 minus 23, 21. 21. So this one. Standard deviation of the distribution of the exam scores is about 13. Which of the following is correct interpretation of this value? So again, think of standard deviation as typical deviation from the mean. Oh, I love it. I mean, it's got to be that, right? It's got to be. I don't need to look at the rest. It's just beautiful. That's exactly what I was looking for. Which of the following distributions has the smallest standard deviation? So I want a lot of data values that are close to the mean. You can see the mean's kind of in the middle. They're all symmetric. So which one has values closest to the middle? I'd say D. The most variation would probably be A. They all have the same scale. There's no values even very far away from that one. So the dot plots show the lifetimes of several brand X and brand Y batteries. What percentage of all the batteries, both brands, lasted more than 42 hours? Give a reason someone might prefer a brand X battery, and then give a reason someone might prefer a brand Y. So what percentage of both brands lasted more than 42? So that would be 1, 2, 3. So 3 out of, good count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Out of 15, whatever that is as a percentage. And then greater than 42, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think 10 out of 1, 12, out of 15 also. And that's 2/3, so 0.666. Repeating. So give a reason why someone, so what is 3 out of 15? .2. Someone might prefer brand X. Okay, so you have the possibility of getting 54 hours or more out of your batteries. So you have the possibility of getting more. Also, you avoid getting a really low amount, really bad batteries, like really low amount. They're more consistent generally, I think, than the others. So overall, I'm pretty sure the mean and median are much greater for brand Y, so that'd be a reason to get that. Professor records how much money in dollars each student has in his or her possession during the first class of the semester. Histograms shows the data was collected. Wow, someone has over $100. Percentage of students with less than $10 in possession is closest to, well, there were 136 students, and about 60-ish of them had less than $10 in their pocket. So what is 60 divided by 136? 44%. Which of the following statements about this can be concluded from the graph? The distribution is left skewed. No, it's right skewed. Median is between 10 and 20. So 136 students. So if you don't know that one in your head, you can just divide by 2. 68. So yeah, it's going to be in this, because 60 is to the left of that, so there's more than 8 there, so it's got to be between 10 and 20. More than 60, I don't know what it is, but that seems too much. The mean is likely less than the median. Actually, the mean is more skewed right. So those are your answers. If you want to double check what I did was right, I did not double check myself. Okay. That's your lesson to your review.